My name's Arie. I'm a clinical doctor, but at the moment I'm doing a PhD in MS. I'm looking for biomarkers of treatment response in people with MS, and the goal is to create a more personalised approach to the treatment of MS so that people will be given, in the future, given medications that we know will work for them before they've even started. So I'm going to give you a very brief introduction today to statistics and how to understand them. And I'm only going to restrict that to the statistics that you need to know about when you're looking at clinical trials. Hopefully I'll be able to do a few more video uploads of other types of statistical analyses which are useful, but I'll restrict it to that for today. I know that statistics is something that's really people find quite challenging, but the only things I'm expecting you to understand today are how to add, subtract, and divide. So as long as you can do those three things, you should be all right. So why do you need to have a good understanding of statistics in clinical trials? Well, I Googled around on the internet to have a look for tabloid headlines for MS, and a few of them popped up. The first was that stem cells claim to cure MS. The next one was an operation by somebody called Paolo Zamboni, I think, who claimed a miracle operation which could cure people from their crippling MS. And it's not just The Sun, it's also the Daily Express who are now claiming that there is a cure for MS which could also be a cure for diabetes. So, again, why do I think this is important? Well, I think Gavin sums it up quite well in the blog. Somebody wrote in a blog, from personal experience, I can tell that doctors are rather unwilling to switch people to newer drugs. And Gavin responded by saying, maybe you should find yourself a new neurologist. We live in an era of the expert patient and patient choice. Gone are the days of the patronising neurologists who dictate a treatment and suggest that and expect you to listen. Treatment decisions should be shared decisions based on the information that is pertinent to you and within the national prescribing guidelines. And that's exemplified by NHS Choices website, which aims to empower people to make the decisions for themselves. So no one's going to pretend that statistics are easy to understand, and I've got a couple of examples here of where statistics can easily be misrepresented. In 1996, there was a claim that breast cancer screening with mammography could reduce mortality by 20%. What this actually represented was a reduction from 5 to 4 people in every 1,000. When people, a sample of the population were asked what that statistic actually meant, 92% of 5,000 women overestimated the benefits of ultrasound screening by either 10-fold, 100-fold, or even more. And it's not just the public who find it difficult to understand statistics, it's doctors as well. 31% of 150 gynecologists who answered the same question also massively overestimated the impact of ultrasound. Another good example here is from the UK Committee of Safety of Medicines, which is basically the precursor to NICE, who warned that the third-generation oral contraceptive pill could increase the risk of potentially life-threatening thrombosis by 2-fold. So they were saying basically that if you took the new pill, you'd be twice as likely to get thrombosis. And as a result, that resulted in 13,000 abortions the following year because people misunderstood the statistics and stopped taking the pill. What this actually amounted to in a group of 7,000 people was a difference between one person getting a thrombosis with second-generation pills and 2 people getting it with a third-generation pill. So it looked like a double-fold increase, but actually it didn't amount to very much at all. And that's because this public study was only reporting on the relative risk. So today, in my presentation, I'm only going to talk to you about 3 statistics that you need to be aware of when you're looking at clinical trials. And the good news is that all of these 3 statistics are pretty much common to every clinical trial you'll look at. The first is the relative risk reduction, which is the column on the left. You then have the annualized relapse rate, which we'll go into why that's important in a bit. You have the absolute risk reduction, and you have the number needed to treat. So those are all the only ones that we're going to discuss today. So let me give you a good example. So this is a representative group of 10 people who've come to the MS Research Day, and when Gavin does his speech, 2 out of 10 of them fall asleep. So that's the event. The event is falling asleep. Obviously, when I'm talking, because I'm younger and better looking than him, only one person falls asleep. So what's the relative risk? Well, the relative risk is just the difference between the event in the 2 groups over the original. So the difference is 2 people fell asleep in Gavin's talk, whereas 1 fell asleep in my talk. So the difference is 1. And the number of people, and the original is the number of people who fell asleep. So the event rate in the control group, which was Gavin. So in that statistic, we say that there was a 50% reduction in the number of people who fell asleep. Well, if that was the case, then you'd read tabloids like this, saying there was a 50% reduction in the number of people falling asleep. What about the absolute risk reduction? Well, the absolute risk reduction is literally just the difference between the number of people who had the event within each group. And the reason why it's important to understand this statistic is that it takes into account the total number of people who were in each group. So 2 out of 10 people fell asleep in Gavin's talk, whereas 1 out of 10 fell asleep in mine. So what you're taking into account here is that the total number of people who are in that study group, whereas in the first example, with relative risk, we're only looking at the number of people who have fallen asleep rather than the total number in the group itself. So here we can see there's only been a 10% reduction in the absolute risk. What about if it's later in the afternoon, everyone's pretty fed up and ready to go home? Well, here, let's say 8 people have fallen asleep in Gavin's lecture and 6 people have fallen asleep in mine. Again, the relative risk reduction is just the difference over the original. So 8 minus 6, which is 2, over 8, which was the total number of people who fell asleep in Gavin's lecture, reporting a 25% reduction in the relative risk, which is obviously less than 50%. The absolute risk reduction, again, is just the difference between the two. So 8 over 10 minus 6 over 10. So an absolute risk reduction of 20%. So in this example, whilst the relative risk is now 25%, so it looks worse, the absolute risk reduction is better because we've taken into account the fact that more people fell asleep in Gavin's group in this example than they did in the first example. So what are the important learning points from this? First, that the relative risk reduction, so the statistic which I mentioned first, doesn't take into account the baseline risk. So how common is it for people to fall asleep in the lecture? You should always check the baseline risk, because if the baseline risk is high, you can trust the relative risk slightly better. And you should also always check the absolute risk reduction, which was the second statistic, because that takes into account the number of people who are in the group who had that condition. The final statistic, which we're going to say is really easy, it's just the number needed to treat. And that's basically an easier way to understand the absolute risk reduction. And it's defined as the number of patients who need to be treated to prevent one additional bad outcome. So in my example here, it would have been 100 over the absolute risk reduction, which we said was 20. 100 over 20 is 5. So we'd have needed 5 more people to come to my lecture to prevent one person from falling asleep. Let's have a look at some specific examples related to MS. So we've got a double-blind, placebo-controlled study. So we've got 100 patients who are being treated with a treatment and 100 people who are given a placebo. In this example, 4 people get a relapse in the control group, and 2 people get a relapse in those who are treated. So that's here, basically. So 4 out of the 100 versus 2 out of the 100. We said the absolute risk reduction is just the difference between the two, so 4 minus 2. And the relative risk reduction was the difference between these, so 4 minus 2, which is 2, over the original number of people who had a relapse, which is 4. So we've got a 50% reduction in relative risk. And using the number needed to treat, it's 100 over 2, which was the absolute risk reduction. So on face value, some people would say, oh, well, this drug's amazing because you've reduced the relative risk of relapse by 50%. But in reality, you need to treat 50 people here in order for this drug to have any effect. This is the same example with different numbers, and it will illustrate exactly what I'm saying. So in this example, we've got 40 people who have had a relapse in the control group, 20 people who have had a relapse in the treated group. The absolute risk reduction, the difference between the two, 40 minus 20. The relative risk reduction, which is the difference, 40 minus 20 over the original, which is 40, 50%. But the number needed to treat here is only 5. So although the relative risk reduction is the same, we've got this is obviously a much better medication because you only have to treat 5 people in order to prevent one relapse. So the most important learning point from this is that you should only really trust the relative risk reduction if the number of people who have a relapse in the control group is high. This is the final example which illustrates that with an even bigger exaggeration. So in this example, you've got 90 people who have had a relapse in the control group and 60 in the treated group. The absolute risk reduction, we said, is 90 minus 60, which is 30. The relative risk reduction, the difference between the two, 90 minus 60 over 90, which is the number in the control group, giving you a relative risk reduction of 33%. But here you only need to treat 3 1/3 people in order for this drug to have any effect. Again, if we were just looking at the relative risk reduction, we'd think on face value this is not a very good drug because the relative risk is 33% versus 50% in the previous example, but actually it's probably the best treatment because you need to treat fewer people. And that's, again, the way that the statistic is derived is by knowing that the number of relapses in the control group is high. So this basically summarizes exactly what I was saying. So if you look, first of all, at the number of people who have the relapse in the control group, that helps you to decipher whether or not you can trust the relative risk reduction. And as you can see, because the number needed to treat, or the absolute risk reduction, takes into account the number of people who have had a relapse in the placebo group, you can trust this drug the most. The learning points there, therefore, which I've just said, are that the treatments with very large risk reductions, like in the first example, may have a small effect in conditions where the control group have a very low event rate. So let's have a look at all of the trials for MS, and now hopefully you'll be able to see that you can actually make something of all of these horrible statistics. You've got all of the trials here for currently licensed disease-modifying therapies. And again, at face value, if you're just looking at the relative risk reduction, these treatments down here look a lot better than these treatments up here. But what I've told you already is that you're always looking at the event rate, so the number of relapses in the control group. And as you can see, as you go down this group, the number of relapses in the control group are getting lower, so we can actually trust these statistics less. And that's demonstrated quite nicely by the number needed to treat. So you're actually having to treat more people with the newer drugs in order to prevent one adverse outcome. So the conclusions of this are basically 3 sentences which all say the same thing. Relative risk reduction depends on the risk of the event in the control group. That low relapses in a control group, such as in the first example I gave you, may yield a very high relative risk, but they're clinically less significant, and that's reflected by the number of people that you need to treat in order to prevent one adverse outcome. And that modest relative risk reductions, such as in the third example, which I gave you of the clinical trials, may be clinically more significant if the relapse rate of the control group is high. So just before you go off for lunch, I'll just finish off by giving you one more statistic. So I started by saying that the tabloids are pretty bad, but it turns out the scientific journals are just as bad. In this first example of an analysis of some of the highest powered journals in the world, in 2003-2004, it showed that 68% failed to report their absolute risks in the abstract. So they only reported the relative risks, which we said can't really be trusted. And furthermore, an analysis of 119 systematic reviews, again in eminent journals, between 2004 and 2006, showed that every second article discussed only the relative risks and ignored the absolute risks, which we said are incredibly important. Good. Do you want to answer?
No. I'm not sure now whether I'm a patronizing neurologist or whether I'm in white armor or whatever, so I'm not sure. What do you think? How do you think? You can say what you think, and then I'll tell you.
I think it's probably a conversation that has to happen between the patient and the doctor, so both people need to be empowered to make those decisions. But I think that, I guess what you're asking is whether how they come to a decision about what treatment is best for you, dependent on all those clinical trials. And I think that having an understanding of those statistics helps to make an informed decision.
So I think most neurologists, most of the time, have some concept of this. So although the table here that you showed gave you a rough idea, you'll see that for many of the medications, it's not too dissimilar. So, I mean, then it's bearing that in mind, but particularly the individual in front of you and what their view is, and having that discussion. So I think
the patient also understanding. So
that's what I mean. Yeah. Exactly. Yes.
I think so. I definitely agree with that. Because the absolute risk reduction takes. I mean, Ben Turner's slides earlier showed the results of a recent trial, and that took into account just the absolute risk reduction. So I think it's probably the most trusted of those two.
I think it's fair to make the point, though, that there are a lot of other things that influence trials. So how a trial performs, even if the same agent, may differ quite a lot depending on the selection. And even when the selection criteria are the same, when you actually look at the population in the end that was in the trial. So you have to, you look at absolute risk and you look at number to treat, but you bear in mind the population that ended up being in that study. And it can be quite different.
Right.
Great.
This is just a kind of message for all the patients I know, and because Matt was asking particularly about risk. Now, this is not relative necessarily to like a last talk, but it is always a decision between you and your neurologist. And the big thing about risk, which is a word which is much bandied about now in many contexts, not just clinical trials, treatments, your perception of risk is your perception of risk. And we know, everybody who works in this field knows that varies between people and that there is no absolute. Somebody can give you some figures, and to one person those figures will say, oh, I wouldn't go near this with a barge pole. To other people, that will be completely different. And I think, at least at our centre, and I'm sure in London, your neurologist will always discuss that with you to try and get to the point where relative risk in subjective personal terms is what's being assessed.
Yeah.
Okay, I hope that might have been a bit helpful.
No, that's a very helpful point, and I think it just, again, reminds us that it's also looking at the efficacy of a drug and the side effect profile and that concept of risk, which is very personal and which will have a different perspective from different people.